idinideklara sa Zamboanga City. At sikreto ng centenarian beauty queen sa Pangasinan, alamin sa buong detalye ng mga balitang yan. Napag-alaman na ang gatuan. Ang panahon sa may maraming kaso ng dengue sa lungsod na umabot sa 170 cases. Ang mula para kay Santa Maria na may 180 na kaso ng dengue. Mula Enero ngayong taon hanggang Mayo 14, nakapagtala ang City Health Office ng 2,026 na kaso ng dengue.
Mag-init ka. Ha? Mag-init. Ganila. Excuse. Ano ba ito? Aninaw?
President
Bagay. Kapapas. Casa Verde. Scarlan. Flores. Andayan. Adina. Linihan.
Present, sir.
Luwares. Lumapas. Lusanta. Maglasyon.
Present, sir.
Present,
Manila.
sir.
Merculita. Nicolasora. Noble.
Present, sir.
Bukay.
Present, sir.
Perez.
Present, sir.
Rimutin. Ruiz. Isabel. Sinyoran.
Present, sir.
Simblante. Corin. Ungab. Okay, isa na tawag.
Muli na, sir.
Molina. Molina, Akain, Algarni. Wala ni no? Inyo. Tirante. So wait lang kadali class ha. I'm using a wrong browser, so I need to open it in Google Chrome, no? So let me exit first. Kailan magkuhan ka exit ha? Just wait for a while.
Excuse me, sir. Naka-mute ka, sir.
Okay, thank you. So we discuss lesson 2.1. This is part of our module number 2 now. And module 2 is all about the vertical datum. So before we discuss vertical datum, so let us first talk about what is geoid and ellipsoid because they are related to each other. So in order for us to understand elevation, ellipsoid light, so these are the model or mga surfaces na ato basihan sa atong measurement for the vertical displacement ng lens. And ellipsoid. So these are the two surfaces nga ato ang kanunay masugatan our topic. And also the relationship between these two surfaces. So ato discuss. And then understand the properties of our ellipsoid and its size. There are different ellipsoid na ginagamit for different countries and it has a varying sizes. Depends on the fitting kung asa sa fit sa inyong locality. Okay, so these are the outline for this class. So mubo lang ni siya, siguro mga 1 hour lang ka discuss. Okay, so I will already give you the syllabus number 1. So hopefully mahuman ninyo ito trabaho, So related rin nga to. So we use the lab number 1 katong ato ang Philippine Geoid Model of 2018. So we discuss about the ellipsoid. Ba naman tayo nila sa inyong geometric geodesy. Discuss nga to the different characteristic and properties as well as the dimension of different ellipsoids in the Philippines, in the whole world. So primarily in the Philippines, we only use the two ellipsoid, which is the WGCT4 for the GNSS receiver and the PRS-92 for the Clark 1866, which is used for mapping and geographic application. So why we use the geoid? Okay, so instead of using the ellipsoid, the ellipsoid surface in measuring the vertical displacement or the height of a point, so we use the geoid instead of ellipsoid. So geoid because ang atong mensel level is not consistent with the ellipsoid surface, Dili siya kumbaga smooth ang mensel level and it is more complex to model, So mathematically, it is difficult to model. So that's why we need to have this our geoid, no? The local geoid in the Philippines. Although we have the EGM, no? The Earth's geoid model of 2008, it is the model geoid model used worldwide, no? But in the Philippines, na-apply ato ang kagalingan, no? So, anong complex man ang atong mean sea level, no? Because mean sea level is the approximate geoid surface, no? So, it is because of the unequal distribution of mass. So, lain man og kuan kanang gibug-aton ang ato ang mga tectonic plates, no? Lain man og iyahang tawag ani iyang mass, no? Na ay daghayuta na uban nga batuon kaayo ang iyang characteristics sa yuta, no? So that's why if you notice sa kuan dapit sa may Nepal, no? Di ba diha daghan kay mga mountain ranges, daghan kay mga batok. So diha nga part ang iyang geoid or the mean sea level will tend to bulge, no? Burot gamay because of the attraction of the mass, no, of the stone, of the rocks. Yes? Okay. Ito na gipakuan. I-accept. Okay. Proceed ta. So, for our vertical displacement, we usually use the elevation. Elevation usually is referred to the mean sea level. It is not referred to the ellipsoidal surface. And the ellipsoidal surface is not directly visible. We cannot access that directly. So if we try to measure the elevation of the point, we usually prefer or recon that measurement from the mean sea level. So that's why we need to use the GEng. Okay? And although it's difficult, no? So there are geodesists try to model the complex structure or formation of the geoid all throughout the Earth, no? So if you notice here, itong illustration ngari, in the Philippines, this one at this part, medyo in the Mindanao area, medyo uwa, no? Because ang iyang geoidal separation, diha nga part is positive, no? Meaning the mean sea level, the surface of our ellipsoid is below the mean sea level. Okay? So geoid is the hypothetical mean sea level, no? Hypothetic, not exactly the mean sea level. Okay? Because the mean sea level is varied. It depends upon the current, the forces of the wind, no? And some other factors nga naka-contribute para ang mean sea level nato mo deviate, no? From time to time. But if we say hypothetical, so if we remove some of the other forces, some of the other factors na act sa ato ang water, seawater, then it will tend to smooth the surface and it will become the geoid. Okay? So geoid is more complex to model or describe mathematically, no? So walay perfect nga mathematical equation to describe the surface of the geoid. So that's why it needs a vast measurement. Na if you notice na tay mga gitawag na to mga airborne gravimetric measurement. So i-measure nila sa mga geodesists all throughout the world, na although dili pa complete, nasa dapit ang ato ang mean sea level, na. So that's why we came up with the model EGM 2008, no? So the geoid is regarded as the as equal to the mean sea level, but not exactly the same, no? Kung wala lain mga factors, maybe they are equal, no? But since the mean sea level is varied from time to time, so karon mo yung level, pagkaugma lain na po na yung level, no? So dili consistent, no? Because naaman tay mga forces na nag-act sa atong dagat. So that's why it is not good to refer the mean sea level kay mo vary na ang iyang elevation, no? So the geoid, if we disregard the other factors, no, itong current and forces of the wind, and the surface created, smooth na siyang surface, no? If you see this illustration here, smooth na yung surface, no? Atong i-zoom in nato, murag smooth, wa na bowed, no? Wa na different forms of waves diha, no? And the gravity at that point, kung smooth surface at ang geoid, not the ellipsoid, the gravity is the same. Okay? So, pareha ang iyang gravity. So, in our module 1, we discussed, dito sa atong module 1 na standard gravity of the geoid, no, or throughout the Earth is around, 600, I forgot the numbers, no? So, nato si Laura, di ba? Si Laura Sanchez ang nag-standardize sa atong mean gravity of the geoid. Okay, so kailangan ko ang standard gravity of the geoid, the surface of the geoid. Okay, so yes, if we remove, ako na nag-mention kanina, if we remove the tides, the current of the sea, then the geoid tends to settle in a smooth undulating shape, no? So why there's an undulation? So matong answer na to ganiha nga it's because of the unequal distribution of the masses, no? Lain man gibug-aton ang atong mga land masses, ang atong mga tectonic plates, no? Depende sa types of rock and types of soil above it. So that's why, di ba sa law of gravity, law of attraction, no? So two body will attract each other, no? It depends upon their masses. So that's why, since the Earth is bigger compared to the land masses, then dili kayo na to manotice nga na ay attraction ang kanang mga Rocky Mountains, no? Na ay gravity attraction, no? Bisa kita, no? We cannot notify that, but there's a slight stronger gravity attraction for the area nga batoon, no? Yung mga regions na daghay bato. Okay? Okay, so this is the reason why there's an undulation of the geoid. So mountain tends to magnify or attract the seawater, no? The mean sea level. So that's why there's a stronger gravity field for the regions that has a mas bugat ang iyang mass, no? So in the Philippines, we have here this kaning findings sa Namria, no? You notice ang nga part sa northwestern part of the Philippines, yellow ang iyang color, no? So there's only small undulation relatively sa WGST4 dili sa ato ang Clark 1866. So relative sa atong WGST4, so ang atong WGST4 mao man ang ato ang reference ellipsoid used by the GNSS, no? It is the model that fits the entire world, no? Not totally fit for a certain places, but majority of the world, no? So here ang Namria nag-provide yung map, the geoidal separation of the mean sea level in the Philippines compared to the ellipsoidal surface of the GST4. So in northwestern Luzon, part, only there's like, I think it's around 8 meters, no? Ang iyang separation, while in the Mindanao area, tuwa, no? So that means the separation is around 70 meters or more, no? So there is a Leyte, very bit nga part. So kung nag-conduct mo atong lab X number 1 sa atong 128A, di ba na ay ellipsoidal height? So if you notice the ellipsoidal height of WGST4 sa atong mga control points, it's around 60 meters, 64, no? 64, 65. So this at this part, no? Ano yung area. So it's puwa-puwa, but may pagka-orange gamay, no? So because na matangari, no? Ari nga part. Okay? So that means to say nga daghan tay mga rocky mountain diri sa southern Philippines, no? Also in the northern Luzon, napot tay mga rocky mountains like in Benguet, no? Mountain Province in Baguio, no? But dili man kaayo dako gud ang ihang area, no? Compared diri sa Mindanao. Okay, so if you notice, di ba naatay mga mining company na sa Benguet, no? Yung ibang sirad-an naman galing sa DNR, no? So they mine the gold, copper, and some other useful materials. In Mindanao, naabot tayo mga mining companies, mas dagandagan sa Mindanao, no? And some of them are still active, no? Until karon, Felix Mining, kanang Rio Tuba, and some other of the mining companies in Mindanao. So daghan tayo mga rocky mountains in Mindanao area. So that's why ang mga daghan tayo mga natural resources, mga atong copper. So we are one of the supplier or the exporter, no? So copper in Southeast Asia, no? And napoy ibang company nga nag-mine og gold, no, sa Mindanao. Okay? So matuon man sa daghay minerals nga makuha. Okay? So in Mindanao, it has the highest giga separation of up to 75 meters, no, relative to the WGST4 na surface, ellipsoid surface. All right. For the relationship between the geoid surface and the terrain, so we have here, ako naman ipakita ni last time, no? So if you look at this point at A, section A, the terrain is below the ocean. So ang nahitabo class, ang ato ang spheroid, no? Kaning yellow natong spheroid na kaning atong geoid is the magenta. So ubos nga ray, therefore ang atong terrain is below the ocean, so negative atong elevation ano, no? And then at B, diri nga part, okay. So ang atong terrain is above the sea level. Nga ang ato ang MSL, ellipsoid, and geoid are almost the same. While at C, ang ato ang spheroid or ellipsoid is above the sea level and geoid, and the terrain is below. So one thing ato makita diri class nga if naga ni yuta, no, bukid nga mountain ranges baka ang atong sea level mo attract, no, mo burot diri gamay. Okay, so just like here may curve gamay, no, towards the mountain. Pero kung naa sa dagat mobali ang iyang curve, paana ang iyang curve, no? Kaya wa man kay attraction sa gravity, wa man kay land masses below the ocean. Okay, so that's why if we look back the grade model GEng 2008, no, so kaning blue diri nga part mo ning ubos, no, This is where the Pacific Ocean, no? And may line. Considering apart, this is I think the Indian Sea, no? Bus po diha gamay ang iyahang kuan na to, ang iyahang gani attraction na ang iyang sea level. So ubos gamay relative to the WGCT4 na surface na to. Okay, so going back. Naman pang apart. Okay, so for the ellipsoid, you know already this, no? Ellipsoid is the 3D 3D shape, no? It is a rotation of an ellipse. No? So why we use ellipse instead of a sphere? So because ang atong Earth, normally it is flattened at the poles, no? So it is good to use an ellipse as a model instead of a sphere, no? Because dili man gyud perfect sphere ang atong Earth, no? Na may medyo flatten man sa pole, no? It's because of the gravity attraction. So both ends of the pole attract each other, the north and the south. So kung sige attract each other, then mulapad ang diri nga part, no? Ang moburot diri sa tunga nga part. So it will bulge at the equator, no? So that's why it's good to use the ellipse as a 3D model for the measurement of positions on the Earth, no? Geodetic positions. So ellipsoid is the approximation of the size or the shape of the Earth, no? So it is better for reference for our location or coordinates or positions of points. Mas maayo man nato siya gamiton as model. So diha na tong mo kan-in nato ang atong mga different coordinates, no? So in your lab X2 na ay mga kahimuon ninyo nga maghimo mo og Excel, no? Sa 1 to 8A ni ha. Hindi mo mag-Excel katong mga equations na akong i-present last time, no? Katong mga tagas kay mga formula. So you're going to make that one in Excel so that you'll be familiar with the formula, and perhaps you can use the Excel during our exam, huh? All right, so ellipse, it is the model na mo natong gigamit. Ellipsoid is the 3D ellipse rotated around the minor axis or the pole. Use that padali, ha? Hello?
Hi, sir.
Correct. Wait lang padali. Okay, naputol. Sige, balik ka. So there are a lot of ellipsoid model used in many countries now. So here in the Philippines, we use the Clark 1866 and WG64, vice versa, no? So na different sizes of ellipsoid used by the other countries. So ako ipakita sa next na pang slide. Okay, na. So for geodetic surveying application, we use the two ellipsoid, the WG64 and Clark 1866. And these are the different ellipsoid model used by some of the other countries. So if you notice here on WG64, Take note sa iyang kuan na, sa iyang lens, sa iyang major, semi-major and semi-minor axis and the flattening. So for the WG64, it is used globally by military and civilian, and for the GPS application as well as for the navigation. No? So its parameters were based from the GRS-80, no? The Geodetic Reference System of 1980. So ang US gihapon mo ay nag-develop ani model. No? And we have here the NAD83. Again, this is based from the WG64. So it is adjusted based from the inconsistencies of NAD27. Okay? So naka-remember pa mo ang NAD27, mama na atong old nga WGS64 ellipsoidal model. And then for the GRS80, so mo na niya ang karong ginagamit, no? Usually, pero ang atong ma-remember kaning WGS84 get that ang mga kuan karon mga geodesist gamit na ang GRS80 na ellipsoid, no? Although there's a slight difference sa iyang length, no? Ang imong tanawon class, pareha ang iyang semi-major, no? But sa iyang semi-minor na ay slight difference. So it's about 14 millimeters ang iyang difference. Okay? And then we have the WGS72. So, mga nang gigamit sa NASA and the Department of Defense and some other oil companies for the oil exploration. So, mga gigamit nila. If you remember, katong APS-G, ilang gigamit sa una. But naglibog man sila, daghan man kayo mga kuan model, so matong ilang himuan ang database. Sa ato ang QGIS, yung na makita mo dito kuan, di ba, na yung mga CRS dito nga number 4326, no? 3251. So ang katong mga oil companies, katong EPSG, mo to naghimo sa database, no? Matong na ay mga ID number ang ato ang different nga mga data. Okay? And then we have here the Australia 1965. So it is used exclusively in Australia. No? Then we have here the Krasovsky for the Soviet Union. I think wala na ni kayo, no? And then we're going to dissolve na siya nga kuan, nga country, no? I mean organization. No? And then we have here the NAD 27. So the kuan ganun na. So it is based from the terrestrial monuments established from the triangulation stations. So in fact, in the Philippines, we also prior to the prior sa mga satellites nga mga tawag ani vehicle, no? So wa pa man sa una gud uso ang katong satellite GPS, no? So mo ni gamit marabag sa ato as solar, no? And then this is not geocentric, no? So ang katong WGS64 geocentric naman siya karon ang kanang GRS80. Geocentric, no? Meaning the center of the ellipsoid is the center of the mass of the Earth. No? So that's what we mean by geocentric. So we have here additional list of the different ellipsoids. So we have here the International 1924. So this is used in the remainder part of the world, no? Ito mga walay naka-assign nga mga spheroid model, then mao nilang ginagamit, no? Then we have the K-Ford, no? Mao ni mga uban nga mga model nga gamit, no? Katong walay mga ellipsoidal model nga defined yet, no? Then we have here the Clark 1880. So this used usually primarily in Africa and France. And then we have here the Clark 1866. It is used in the North American region, no? Sa Canada, sa mga nagagamit. And here in the Philippines. Then we have here the Airy 1830. So manigamit sa Great Britain. And then we have the Vessel 1841. So manigamit sa Europe, Chile, and Indonesia. And then we have here the Everest 1830. So suli na ano siya tukuan lapit uh, sa may Thailand, no? India, Thailand, kanang mga region Pakistan, Burma, and other adjoining countries. Okay? So, if we examine if we compare the two spheroid, no? Clark 1866 and the WG64. So, their center of the spheroid is separated for about 236 meters, no? So, medyo layo agad ang iyang displacement, no? So, depende mo na kay ang ato ang Clark 1866, it is topocentric to the Philippine island, no? So, it is fitted for the Philippines. So, that's why we have the different, we have the rotation parameters, no? Ito nga kung ipakita last time. Okay? So, these are the parameters for the gi-rotate man, no? Nga gi-orient and gi-displace gamay ang Clark 1866 nga spheroid. So, that's why we have here the translation. So, gi-displace na to. So, kung imo ning i-spherot, kani nga value, kani i-add nimo nya imo i-add nimo ang squares ani nya i-square root nimo cube root square root square root nimo, so the distance is around 236 meters. Okay, sige daw na may calculate. So don't forget to kaning value, the different translation, no? Translation siya nga parameters, and then we have the rotation parameters. I-rotate nimo ang axis with regards to the initial natong axis, the velocity stiffness. Then we have here the scale. So by the way, ang atong scale diri class, scale parameter, this is in parts per million, no? ppm. So it is 1.06002 ppm. Okay? So, basig malipat mo sa atong formula, ang atong gikuan dito, I think the input is parts per million, no? But there are other programs and software that kailangan imo i-input is naka-decimal nga scale. So, since per million man, so you need to multiply this by times 10 to the power of -6. Okay? Questions? Clarifications? Long time no see, no? So, I am busy sa ako ang mga gipang-assign nga task ni Sir Bong. So, we are having our research agenda, no, na may mga activities. So, kato sa landslide. So, that's why ako naka-klase pagkahuman sa typhoon nga agaton. But anyhow, we try to cope up with the remaining days. So probably we'll be having our meet-up class. So next na to nga mga days, puro klase na ta, and then natay mga exam. So di na ko kayo maghatag og exam. I'll be focusing more on what is the what have you learned, no? Di na ko kayo kato magpalit lisod-lisod. Naga pa yung mga lisod gamay, no? And hopefully sa inyong part as a student, no, dili mo magkuan kana bitaw mong salig mo sa inyong classmates kay na answer, no. So I know nga kamo uban sige ra mo diha og pangutan anay, no, sa chat box kita na niya dito si answer nimo anay number 1. So I hope nga kuan lang na mo na learn, no, if you try to ask something from the classmates na may na-learn, no? Di lang purely as in ang answer